How's it, grade 12s? Today we're going on to the midpoint theorem, slides 41 to 47 from the PowerPoint proportionality. So what this theorem is saying, it's saying the line joining the midpoints of two sides. So here we have P as a midpoint of this side because that's equal to that. And then over here we have Q is the midpoint of the side AC because that is equal to that. All right. So the line joining two midpoints of two sides of a triangle. So here's our line joining the two midpoints is parallel to the third side, which is this BC side, and it's equal to half the length of this side. So given triangle ABC, the big one, with AP equal to PB, AP equal to PB, and AQ equal to QC, then what can we say? We can say that this QC side is parallel to this BC side, and the length of this PQ side is equal to half the BC side. Now, with your statement reasons, the reason that you would use for this is midpoint theorem. Okay, moving on to the converse, which is just the opposite of this. I'm going to read it out to you first. It says, the line passing through the midpoint of one side. So there's the midpoint of one side, the line passing through it, of the triangle, parallel to the second side. So this is parallel to this. Bisects the third side. So if we have the scenario that this is the midpoint and it's parallel to this, then it bisects this side over here. In other words, this length will be equal to this length. So let's have a look. Given triangle ABC, which is the big one, ABC, with AP equal to PB, and this PQ parallel to this BC, what can we say from that? Then AQ equals QC, and the length PQ is equal to half the BC side. And for your statement reason, you would have converse midpoint theorem, just the opposite of that previous theorem. So if we look at example 1, okay, let's just do a statement and a reason column. They've told us here that in triangle PQR, so in triangle PQR, we have that PS is equal to SQ. So this side is equal to this side, and ST is parallel to QR, this long side at the bottom, okay, with WT, grade 12s, with WT parallel to QP, okay, so with this WT parallel to QP. Okay. We have to prove that SW is parallel to PR. So SW is parallel to PR. So what I want to do here is just color code some of these parallel lines. So we've got this is parallel to this, and this is parallel to this. Okay, and we want to prove that SW, this line here, is parallel to that one. So just by looking at this, if I've got that this side is equal to this side, I can prove, so that's with the SW there. Now, if I can prove that QW is equal to WR, then I have that this side is equal to this side, that side is equal to that side. So I can use the midpoint theorem and show that that is equal to that. So that is my aim of my game. And I'm just going to put here QW equals WR. That is what I'm going to try and prove. Okay. So first of all, what I'm going to say is I'm going to say that PS is equal to SQ. Okay, PS is equal to SQ. That was given to us. Also, what was given to us was that ST parallel QR. So the green one, ST parallel QR. Now, what can we say from that? Therefore, because we have that this is equal to this, and this is parallel to this, therefore PT must be equal to TR. Okay, so therefore PT must be equal to TR. And what did we use there? We used the converse midpoint theorem. So converse midpoint theorem. Okay, so now that we know that this is equal to this. Okay, and what else do we have? We have that TW parallel PQ. So we have this TW parallel PQ. Okay, that was given to us. Now, because this is parallel to this and this is equal to this, that means that RW must be equal to WQ. Okay, we are using the converse theorem again. So therefore, QW must be equal to WR. Okay. And because now that we have that this is equal to this, we got what we wanted. Okay, so that means that SW must be parallel to PR, because we have this side is equal to this side and this side is equal to that side. So you see that is our midpoints there and our third side. So therefore SW must be parallel to PR, and the reason for that one was midpoint theorem. Okay, that was a pretty easy one. Okay, moving on to example 2. Okay, so example 2 has got quite a bit going on here, so I'm just going to read it out. It says that ABCD is a parallelogram. We have that Q, R, S, and T are the midpoints of AB, BC, CD, and DA respectively. Prove that this QRST shape is a parallelogram. Okay, so I'm just going to mark in here, because this is the midpoint. I know that this is going to be equal to this. This one will be equal to this one. That one will be equal to that one. And that one will be equal to that one. Okay. Also, what I'm going to do, this is how I'm going to have a look at it, grade 12. If I can prove that maybe this side is parallel to this side, and if it's equal in length, both of them, then I must have a palm, because that's the property of a palm. It's the opposite sides are parallel and equal. Okay. So in order to do that, all I'm going to do is I'm just going to draw a line through here. And you'll see now why I've done that. Because I've got this is equal to that, and I have that is equal to that. That must be parallel to that. Okay, that is your midpoint theorem. Vice versa on the other side. I have that this is equal to this, and that is equal to that. Therefore, that must be parallel to that. Now, since this is parallel to that, and this is parallel to that, they must both be parallel. Okay, so that is my thought process on how I'm going to do that. And then I will tackle the length issue as I go along. Okay. Okay, let's go for it. So the first thing I'm going to do is I'm going to say that AT is equal to TD. So AT is equal to TD. That was given to us. Also, we have that AQ is equal to QB. So that is equal to that. That was also given to us. Okay. Now, because of that, I know that, therefore, I know that TQ will be equal to half the length of BD. Also from this, we know that TQ will be parallel to BD. Both of those came from the midpoint theorem. Okay, so now that we know that this is parallel to this, also we know that the length of this is equal to half the length of that. That was one thing that we did. Okay, now I must just do it for this side over here. Okay, so we have that CS is equal to SD. CS equals SD. That was given to us. We also know that CR is equal to RB. CR equals RB. That was given to us. Okay, now because of that, I know, therefore, the length of this side will be equal to half the length of that one, and that will be parallel to that. So, therefore, RS is equal to half BD. Also, we know that RS will be parallel to BD. Both of these come from our midpoint theorem. Okay, so what I want you guys to note here is there's a half BD and there is a half BD. Now, because both of these are equal to half BD, they must be equal in length. Okay, so therefore, from this, we know that TQ must be equal to RS. Okay, and I'm just going to put here both equal a half BD. We also know that because from here, they both parallel to BD, that means that TQ must be parallel to RS. So we know here now that TQ must be parallel to RS. I'm just going to put it in here, you don't have to, but both parallel to BD. Okay. Now, because we've proved that this side is equal to the length of this side, also we've proved that this is parallel to this, we must have a parallelogram. Therefore, TQRS is a palm. And our reason for that is one pair, opposite sides, equal, and parallel. Okay. So grade 12s, what I would like you to do is exercise 6 for me, please. Thank you.